the deal. You guys just dove into some graphing and some factoring. I'm going to look at a couple graphing on this skills review thing, but I think you're on to the big to-dos of factoring. Somebody came up to me and said, are these the easy kind, the like B, if I look at part B? Are those the ones that I can just do the factors on the end that add to the middle term? That was kind of the terminology they used, and I said, yeah, that's right. So these are if there's no coefficient out front, those are easy. And they said, can I just think of it that way? That's fine. You don't need to get complicated. I think you're all pretty clear. I think it's minus, does it work? Minus 6 plus 1. Those are factors of the last term that happen to add to negative 5. So this factor is like this. And again, the big point of factoring is not because somebody says to do it. These forms have benefits. There's something that we like about these. And so I'm going to use this as a chance to kind of show you that real fast. Why would we ever want to do this? The thing is, I can draw a parabola with this information. By the way, this is on the skills test. And about all I can tell you right now is that's a parabola facing up. That y squared, the fact that it's positive y squared means it's a parabola facing up. That's all I really know. But in factored form, there's something really cool about factored form. We can actually, there's some neat information about it. If you remember, you can always plug numbers in to like a table and make a table of values and start plotting points, and it gives you a picture. That's what graphs are. It's just a collection of points. And I'm just going to put, the whole expression over here because you guys might be confused that I'm using y as my input. But the idea is if I take a particular y that I choose and I get out some result, like 0 is always a favorite. Put in 0. If I put 0 into there, I think if I work it out, I get negative 6. Doesn't matter which one you plug it into, but that makes this 0 and 0, and you're subtracting 6. So what these expressions do is you're supposed to have a mental image of what it looks like, and that's where we're headed, is you guys can picture that. Well, all I know right now is it seems to hit, when the input is 0, I get hit negative 6. I'm just going to take a guess on this one. Maybe it's, I don't know, something like this. Maybe it hits like that. So that's maybe an image in my brain. It hits when the input is 0, it touches at negative 6. But to refine that, factored form, it has other things that are good about it. It's really easy to plug some special numbers into the factored form, like what we call the zeros. Remember putting things in here that make it 0? If I put 6 into that factored form, you instantly get 0. And you guys know that if the left-hand side is all 0, then times I don't care, I'm going to get 0. So it's a really quick way to go, oh yeah, if I put 6 in there, I'm going to get out 0 no matter what. And it's harder to do that in the original form. In the factor form, it's a no-brainer. I put 6 in here, I got this. So we like factored form because it's really good at picking out what are called zeros. It's easy to find where the graph has a value of 0, where the expression has a value of 0. 6 is one of them. Do you see the other one? Put negative 1 in there. It's kind of jog your, that's called a 0 as well because you put it in. If I put it in on the other side, it gives me negative 7, but I don't care. 0 times negative 7 is 0. So those are the things that I just found relatively quickly are values that are easy to figure out. And the first one, if I put 0 in, it's easy to get negative 6. In factored form, if I put in what are called the zeros, the things that make the factors 0, I get these little outputs of 0. These are like x-intercepts. Does that sound like that's an old school, like these are called x-intercepts, where the height is 0. So in this graph, I can look and say, all right, when I put in 6, I got out 0. Be like right here. And when I put in negative 1, I got out 0. That means I drew my graph kind of poorly. That means it probably looks more like this. Now, I don't expect you to be fluent doing that, but that's where factoring kicks in, is that it helps us look at something differently. We notice stuff that we didn't notice before. So love factoring because it helps you get an image, and we want to be able to picture graphs because these dumb calculators are going to mess you up. Now, how about E on this one? So we have some factoring. If you're on that skills test, you want to see some more factoring because a number of you you're getting there. You're getting better at it. It's been a long time since we've factored, but it is a bit of a trick, but it's an important one that you want to have some fluency with. Like 2w and 1w are factors of that leading term, and they always go first. And then we need the factors of 9 that we can pair with it, positive 9, that will help when I multiply them together. I get a sum of negative 4. So let's see what we got. Ready? Does 2 times 9, 18, and 1, not even close. That's like off the chart, so you get too big. And 2 times 1, and you add 9 to it or something. Oh no, way too far off. So that, I'm going to go 2 times 3 is 6, and take away, no, not looking. Does this one work at all? Did you find anything that works? So we get these, it's not factorable for whole numbers. I could do it with fractions, but that's not the type of thing I'm looking for. So it's not factorable with whole numbers, just factorable with fractions or decimals. No big deal. Now over here, I think this one worked out better, maybe. I hope so. And then 2 and, no, 2 and 1. Oh. First you gotta write the right factors. I'm backing up. I saw it. Sometimes I don't. But it looks like 4 for multiplying 2 times 2. That was cool. And 1 times 1. Add those together, you get 5. Yes. So your job is these two go first, 2x and 1x. Always do. And when I paired them, I did 2 times 2. Don't put that 2 with the other 2x. Don't put them together. They always go in opposites. Never put them in the same parenthesis if you multiplied them in getting that middle sum. So that's the only rule to it. That's the factored form. We know it and love it. If I wanted to find the zeros, which we do a whole bunch later on, you guys are eyeballing it. Maybe you're thinking negative a half, that'd be a good 0, and negative 2. I'm not asking that of you now, but I want down the road, those are things that become important, noticing those really fast. I got the zeros. I know where it hits. Okay. So that is where you guys were. Now, the next thing was, hey, quadratic formula. So we had to go through one of the ones I did up on the wall, sitting right here. And then the other one that we didn't get a chance to do is same thing, quadratic equation. There are cases sometimes when you do the quadratic equation, you get one or no solution. So I'm interested in knowing if you guys ran into a situation where there were no solutions. And we're going to look at that here in a second. So hang tight. By the way, the recording